Okay, welcome to lecture 4, part 5. This is the last part. Okay, when we left off, we had just seen the box plot, and we saw that we could get confidence intervals, and we could do this all within Simio. So we're just doing this within Simio, and for this work, we can just stick to Simio. It's important that you have R, of course. I posted the instructions how to install that. We're going to need that later on, and we're going to start using that soon. But for now, we're just going to keep learning about Simio. Okay, so here's the question. Do we have the right number of baristas? Should we have more? Should we have less? And we're going to consider the cases of having 1, 2, 3, or 4 baristas. Okay, so how do we figure that out? Well, we're going to want to run the experiment we just designed under 4 different cases, the cases of 1, 2, 3, or 4 baristas. To get there, you go back to your navigation window and you click on the model. Okay, and note how that navigation window, now we can go back and forth between the design of experiment by clicking on that, or going to the model by clicking on model. Okay, what we're going to need to adjust is after you click on the barista object, we're going to want to adjust the initial capacity of the barista using we call a control in Simio. Okay, so if you click on the barista object and then you right click on the initial capacity. And when I say right click, you're going to right click on this part of it. So where the grade initial capacity. And you're going to see there's 3 options. You want to set the referenced property. Okay, when you click on that, it's going to bring up another. So this is one of these nested selection boxes. So just be aware that you right click and then you left click, and it's going to actually keep the original thing up. You can see it has it up, and then it brings up the menu. You want to go all the way to the bottom and create a new referenced property. Okay, that's with a left click now. Okay, so it'll bring up create new property, and it's called barista underscore initial capacity. That's fine. You can leave it like that, and you just click OK. So that's now this name. Okay, so now if we go back to the navigation window and select the experiment 1, we see in the design tab that under controls, we have initial capacity here. Okay, that's now there. So now we have to click reset. And now we can start playing around with that. Of course, we're also going to want to add responses relevant to the barista. Okay, so we're also going to look at barista queue time, and then we're going to add the response barista queue time here, because that's going to be something we want to see as a function of how many baristas we have. So add that response as we did before from the last slide. If you forget how to do that, go back to the lecture part 3, where we were adding responses. Okay, so now we're going to set up the experiment. And what we want to do is we want to duplicate it. So if you see if you go back here, you're going to see in this, if you click in there, it'll automatically create a scenario 2. And it'll create this little black thing down here now. You click there, you get scenario 3. Click there, you get scenario 4. That's all we need. And then for the initial capacity, you just select that to be 1, 2, 3, or 4. Okay, for the barista initial capacity, you can now change that to change the experiments. Okay, so now we've set up the experiment, and you see we have this new field, barista queue time, a new response. We're going to now run the experiment. It'll run 4 scenarios with a different number of baristas, and it's going to run each one 100 times. Okay, so if you run it, it's going to give you a bunch of these statistics in the table for our responses. And now we want to see, well, how many baristas should we have? So let's look at our charts and see if that gives us any insight here. You can see if you click here on, you're going to want to click on response results again. And when you click there, you can see if you click for barista utilization, you can kind of see we have 100% utilization of one barista, which means it's busy all the time. You have 60%, 40%, down to 30%. A lot of times ideal utilization is considered to be between 70 and 85%. So we don't really have that. I guess you could argue one of these two, one or two baristas would be ideal. The idea is, of course, you don't want a barista sitting around doing nothing. So now let's look at the time in the barista queue. And you can see why we added a second response. Usually there's multiple different statistics we want to consider when we're making a good decision for a sophisticated question. And this sort of gives us the whole answer. You can see there's quite a bit of time wasting in the barista queue with one barista and almost none with two. And here, in economics, we talk about something called the law of diminishing returns, and it just means the marginal gain from adding a resource decreases as the more resources you add, and you can see the law is actually being executed here. After adding two gives us a ton of return, but adding 3 or 4, it doesn't really give us much return at all. So it seems to me that this isn't still the whole question. We might want to look at cashier utilization. When we look at there, it's basically the same. So the number of baristas doesn't affect cashiers, which actually makes sense if you think about it, because it's not like customers go back to the cashier. They go once to the cashier and then to the baristas and nimmits. So the cashier shouldn't be affected by baristas. So this should make us feel, okay, this is reasonable. And so what we can conclude from this is that two baristas is supported by our model. Okay. And that's what you would report back to the decision maker. Always be careful not to oversell your results. You really want to say something, caveated by the fact that we're using a simulation model and we've provided evidence that two baristas is best. And here's the evidence to back it up. Some things to avoid saying is it's clear that it must be the case that two baristas is always better. That's too strong a statement. Remember that we're using a simulation to set up an experiment, so the strongest statements we can make are that we're building evidence to support a conclusion. In this case, our simulation model has provided a lot of evidence that two baristas is going to be the best number of resources to have